series is an approximating function. It is an approximating method where we will take any non-polynomial function and represent them or expand them in terms of polynomial function. So what is polynomial function? We have x and its power is 0, we have x its power is 1, we have x its power is 2 up to x its power is n. Now we are missing here coefficients. Here some coefficient that we can say is a0 or a1 or a2 up to an. So we need to find these coefficients. Okay, these coefficients, let us suppose we are having this x naught. So what's x naught? We can say that it's not varying with respect to x. Whatever will be the x, this term says that it is constant. It is a constant value. Okay, so whatever is x here, it will be constant. So this term. So if we are having some function we are representing, let us suppose we are representing sine. So this sine function, we have to know whether this sine function, when we will represent in terms of the polynomial, whether this coefficient is there. So let us suppose now this a1 of x, what is represented? So we can say that it is a and x, we can say that it is y is equal to mx plus c, where c is 0 and this m is slope, that is a1, and this x is any value here. So we can say that it is a straight line. Okay, we can say that it is a straight line that is passing through 0, and it can pass through here also if we are having this c value. So let us suppose we are having this sine function. Okay, this sine function we approximate it with this polynomial, that is a naught of x naught. Now we have approximating it using this line, and what is this? It is a1 of x1. So the third term, that's a2 of x2. What a2 of x2 is, it is something that is like this. Why? Because whatever be the x, either minus x or plus x, so value will be always positive. So this will be like this term of growth. So till now we have approximated the function using this and this. So what the value that will be this a naught x naught, this value we need to calculate. So let us suppose this sine function we are having. So how we will calculate this a x naught? We know that x naught is not it will not affect here, it is same everywhere, but it is x raised power 0, that's 1. And a naught, how we can calculate a naught? Just put x is equal to 0, because we are calculating the value at this point. So it will be sine 0 is 0. So we know that now a naught x naught is equal to 0. Now we need to calculate this a1 of x, a1 of x1. So we need to calculate this a1. So how we will be calculating this a1? Let us suppose we are having this sine function, we are approximating, we are expanding it. So we know that we will be having some line. So whether this line will be this way or this way, or it is a line. Okay, so how we will calculate it? We know that we want to draw some tangent to this curve. Okay, so the tangent should touch the curve at some point, so it will give us this approximation term. So how it will be done? It will be done if we are having some, let us see that we are having this curve, we are drawing this tangential line. So what is the equation of this tangential line? It is m x plus c. So plus c is here 0, and this m, how this m will be? It will be done this way. So it will be slope, means basically y2, let us suppose this is y2, this is y1. So y2 minus y1 divided by, this is x2 and this is x1, x2 minus x1 multiplied by x. So this in turn, this is a slope, that's m. This is also called the first derivative, f dash of x. It is same as if we do d divided by dx of sine of x. What is d divided by dx sine of x? It is cos of x. And what is cos of x? It is 1. So it means that a1 of x1 is equal to this a is now 1 because the first derivative means the slope here is 1 and x1 means the first degree polynomial value coefficient is 1. Now we have to calculate a2 of x2, but this x2 in terms of this Taylor series, what we will represent actually it as a2 of x minus a whole square. This whole square will represent the quadratic term, but and this a means we are evaluating at a means, let us suppose we have this sine function. If this is this is the point, that is a. Here we are evaluating this, and this x is the a near random value. So let us suppose this a we put at 0 means we are evaluating the function at this point 0. So then this x can be written as x square also. Another way is we can put this a plus h. If we put this a plus h, we know that this we have to represent as x minus a, so it can be represented as x minus a. Why this x is a plus h minus a will be cancelled, we can represent it also as h square. So now we have to calculate this a2 of x2. So in turn we say that we have to perform d divided by dx of sine of x, but 2 times we have to perform the differentiation because we need to know the second order derivative, means second order coefficient. So we will perform 2 times and we will get some coefficient, that will be the a2. Same way we can calculate the rest of the coefficients, and we will have the value for every coefficient in Taylor series. That is, we are having this a naught x minus 0 factorial plus a1 x minus a here 1 divided by 1 factorial plus a2 x minus a2 divided by 2 factorial plus dash, or we can represent it as this a we will be calculating using the derivative f of x. So we can say that f of a derivative, here we can write it as k, and we are having this x minus a and it is also k. So k is rounding from 0 to n, and we have to get derivative of this factorial of this is the Taylor expansion of any function we can